We started our week by defining what tidy data is, and then we worked with tidy data frames, either a single one first to kind of transform it in a variety of ways using functions from dplyr, and then worked with multiple tidy data frames and joined them together. In this last video, we're going to be talking about tidying data. So what if I don't have the tidy data to begin with? And actually, I don't mean that I have messy data, but what we have is data organized in an unideal way for the analysis we want to do. And what we want to do is to reorganize the data to carry on with our analysis. So going back to that grocery sales example from the previous video, imagine that we have data in this format where I have one row per customer. So I had two customers to begin with. And so two rows in my data frame. And then I have individual columns for the items that they bought. The first customer had bought 3 items, bread, milk, and banana. So that's the 3 columns I have for them. And then the second customer had only bought milk and toilet paper. And so I only have data on the first 2 columns for them. And the third one is NA. But what I want to do is to have it in the format that we've seen earlier, where I have one row per customer per item, okay? So that I can do further analysis with. So that's the goal that I want to get to. So how do I go from one to the other? For this, we're going to use a new package from the tidyverse called tidyr. So again, it's from the tidyverse, so I can just do library tidyverse and get access to it. And the tidyr package provides a variety of functions. Mostly it can be classified under these 4 bullet points. Pivoting for going between wide and long data, and that's what we're going to focus on in this video. Later on in the course, we're going to touch on some of the others as well. Splitting and combining character columns, nesting and unnesting columns, and clarifying how NAs should be treated. So an example for that is, if I go back to the previous slide quickly, this third item by the second customer shows up as an NA here, but if you were the person who were doing bookkeeping to begin with and just, standing outside of a grocery store with a clipboard and saying, okay, here are the items each of these customers have bought, you probably would have never entered that row there. You would just say the second customer only bought 2 items, and you would have ended up with only 5 rows as opposed to 6. So that's what I mean by clarifying what to do with NAs. Do we want to have that or do we not? And depending on the analysis you want, that might be a useful consideration. So focusing on pivoting data, if you've ever seen Friends, when I say pivot, you're probably thinking about this, but this is not what we're going to be talking about. We're going to be talking about a different form of pivoting where we take data from wide to long. So looking back at the data sets that we started with, the wide data frame, the one that we started with is the wider data frame. And I want to avoid saying wide or long, but instead focus on wider or longer. For any given purpose, one data set might be wide or long, depending on the next thing that you're going to do. But what we're trying to do is, are we trying to make it wider or are we trying to make it longer? Wider meaning start with something and add more columns to it. Longer meaning start with something and add more rows to it. So if you are the person who is, let's say, collecting data outside of a grocery store, you might again have a clipboard in your hand, a row per customer, and then you start writing the items they buy. If you're doing this across columns, you're creating a wider data frame. And what we want for this particular example is a longer data frame. So we want to go from wider to longer. So we're going to use a function called pivot longer. The pivot longer function, just like any of the other functions in the tidyverse, starts with a data argument as usual. Then we want to give it the columns we want to pivot into a longer format. So which ones are we going to pivot? And then we want to give it an argument called names to, which is the name of the column where the column names of the pivoted variables will go. And the last argument is values to, which is the name of the column where the data in the pivoted variables will go, which is also a character string. So basically, we're constructing 2 new variables. These are variables that didn't exist in our original data frame. Since we're just constructing them now, we are going to give their names as character strings so they can be placed as these character strings in the headers for those columns. Putting things in context, if I want to start with that customer's data frame that I had, which had only the 2 rows for each of the customers, and I want to pivot it longer, I'm going to say the columns that I want to pivot are the ones that have the information about the items that the customers bought. So that's items 1 through 3, and I'm indicating this through with the colon operator. We could also use these select helpers here and said something like if it contains the character string item or if it starts with the character string item, but we didn't do that. Any one of these would have been fine. The names, item 1, item 2, and item 3 should now go into a new column, and I'm going to call that column item no. So that's the item number. And the values from, so the information that was in the cells should go into a new column called item, and that's going to be basically where whatever the customers had purchased is going to go in there. So the column names from the original data frame go into a new column called item no, and the values in these columns go into a new column called item. And I end up with a data frame with 6 rows and 3 columns. Now, why might I want to do this? Why did I want to pivot my data? Most likely because the next step of your analysis needs it. So if I wanted to get these data and then join the price information I had on these items that are purchased from the grocery store, I can then do things like calculate total revenue and whatnot. I can also go back. Just like I went from customers to purchases, I can now take this purchases data frame that I created and go back to customers. So I did the pivot longer action to go one way, and now I can do pivot wider to go back. The first argument is going to be the data as usual, which basically gets captured using the pipe operator. So the purchases is the first argument of pivot wider here. The names from basically tell me which column in the long format contains what should be column names in the wide format. So that was the item no is going to go back, and the values in that item no column are going to be the names of the columns in the wide data frame. And values from basically tells me which column in the long format contains what should be values in the new columns in the wide format. So those were the names of the items that were stored in item. Note that these are not quoted because these are variables that exist in my data frame, and I'm just saying grab information from them and put them elsewhere, as opposed to construct new variables that didn't exist where I'm just feeding it variable names. So to wrap things up, let's look at a realistic case study where pivoting the data might be helpful. And we're going to look at data on approval rating of Donald Trump. And there are a variety of polls that look for this information. But the data that we're going to use comes from the 538 blog, which is like a database politics blog. Actually, not just politics, sports and whatnot too, but mostly data-based articles. So what 538 does around, year-round, to be honest, and then gets really active during election times is that they take a look at polls and they run some models to aggregate information from polls. So the modeling aspect is not what we're going to focus on today because we haven't learned about that stuff just yet. But we're going to take their aggregate model results as truth, and we're going to look at working with those model results to do a visualization that looks similar to the one you can see at the referenced web page, which is basically looking at how popular or unpopular is Donald Trump. So the orange line is the disapproval rate over time during his entire presidency, and the green line is the approval rate during his entire presidency. You can see that there's a drop-down menu on the website that says polls of adults. You can look at 3 other versions, but we're only going to focus on the 2, polls of all adults and then polls of likely voters. So the data frame that I got, which I downloaded off of the 538 website and just did a little bit of cleaning to make it more accessible for this particular video, is called Trump. It has 2,702 rows and 4 columns. One of the columns is a column called subgroup. And as I said, we have two levels for that, either voters or adults. So is it likely voters that the data came from the polling data, or all adults? Then we have the date when the model was ran based on the polling aggregation that was being done. And so we have two observations per date here, one for voters and one for adults. And then for any given day, we have the 538 estimate for the approval rating. Now, I want to be very clear. This is an estimate based on their models. This is not some hard truth. 538 tends to be pretty good at their estimates. They're also pretty transparent about how they do the estimates. So if you want to read about them, you can go ahead and do so in their website. But we are plotting the data as we get from them. So we should cite that as our source. But note that there is likely error bands around these estimates that they're reporting, since these are simply estimates and, again, not the ground truth. We can see, though, for example, for the model estimates that for likely voters as of October 4, the approval rating is 44.7% and the disapproval rating is 52.2%. This is the visualization that we're going to construct as a result. It looks very similar to what 538 had on their website, just a little bit different. One, it's not dynamic, and two, I'm only looking at the estimates as opposed to the error bands. So what do I have here? If this is my ultimate goal, I need to think about what are the pieces that go into the puzzle. On the x-axis, my aesthetic mapping for the x-axis is a date, and I know that I already had that in my data set. I'm good to go. On the y-axis, I have an approval rating, but note that in the original data that I was working with, I didn't actually have this information in a single column. I had it spread across two columns as approval and disapproval, but we know that when we're making ggplots and we want to say put this variable on this axis, we actually need that variable to be, we need that information to be stored in a single variable. So I need to do something to my data to create a new variable that actually has the rating value. And obviously, I don't want to confuse between approval and disapproval. I'm going to need to maintain that information that is currently captured as the headers for the columns as approval and disapproval in another column called rating type, and that's what I'm going to color things by. So I'm going to color them orange and green based on whether it was an approval or a disapproval. I also see that I have faceted this visualization for adults and voters. On the 538 website, this was an interactive visualization with a drop-down menu. For now, we're just making static visualizations in the course. So instead of giving the users the choice to choose between them, I'm giving them both, but faceting. So I need to facet by whether the model estimates is for adults or likely voters. And that information I already had in my data frame under the subgroup variable, so I'm good to go with that as well. So really what I need to do is to reorganize my data a bit to create two new variables, one called rating value and the other one called rating type. The rating value is currently stored in my data frame in the cells of the approval and disapproval columns, and the rating type is currently stored in my data frame in the column headers of approval and disapproval. So what I'm going to do is I'm going to start with my Trump data frame, and I'm going to pivot it longer. And so I had the approval and disapproval as columns that appeared next to each other in a wider format, but I want to actually pivot my data longer. The columns that I'm pivoting are called approval and disapproval. The names of these columns are going to go into a new variable called rating type, which will take on the values either approval or disapproval. And the values are going to take the values from these columns are going to go into a new variable called rating value, which is going to be the values in those cells. And note that as a result, I get a data frame of size 5404. So this should be twice the size of what I had started with, because instead of having the approval and disapproval rating spread across two columns, I now have them underneath each other in a single column. Now that I have this information, let's take a look. I have date, which was going to go on my x-axis. I have rating value, which was going to go on my y-axis. I can color by rating type now, and then I can facet by subgroup. So let's go ahead and take this trump longer data frame. So note that I have done the pivoting, and then I have stored the result as a new data frame called trump longer, and I'm going to use that in my ggplot2 call. So x-axis is date, y-axis is rating value. We want to color our lines by rating type. And here is a new ggplot2 functionality that we didn't touch on last week when we introduced ggplot2, which is that if you want to have lines that are joined, so instead of drawing a smooth line or representing your data with points, if you want to basically draw a line joining each of the points in your data frame, you need to tell R which groups to join the lines by. So I also need to say when you're drawing the lines, draw one line for approval and one line for disapproval. So I need to add a group argument for that, and I'm using a new geom called geom_line. And we said that we wanted to facet by subgroup for adults and voters, so that's what we're adding as the last layer. Here is a typical ggplot that you can get out of this, but remember that our goal looked a little bit different like this. We had a few more things happening. First of all, we had in the goal plot that we want to get to, I was using orange and green for approval and disapproval to match the scales used on the 538 website. So since I am basically defining the colors manually, I can add a new layer using scale color manual. So the color comes from the fact that it's the color aesthetic that I'm trying to manipulate, and the manual meaning that I want to manually provide some data, some values for you. And basically I want to say I want it to be dark green and orange. R is not going to recognize just any color name, but there is a list of color names, a really long list of color names that it does recognize. And if the color you want isn't one of those, you can look this up easily what those list of color names are. If it's not one of those, you can actually give a hex code for the color as well. Then I also want to do a little bit of a better job with my labels. So my x-axis and y-axis. One thing I've done here is I've said, don't give a label for the legend. So for the color, I get a, if you remember, I get by default a label for my legend as well that tells me which variable this information came from, approval and disapproval. So that was rating type before, but I don't really need that information. It seems redundant to me, so I'm just going to say leave it alone, leave it as null. Then I give it an informative title and a subtitle, and I also added a caption to my plot to actually note the source that I'm using for my for where these data are coming from. So let's go ahead and take a look at what that plot looks like. So here is the appropriate labels, no more legend label, but I am still not exactly where I had started. We're going to do two more things. One is use theme minimal, which will get rid of the gray background for us. And the other one is to move the legend from the side to the bottom, just so it doesn't take up so much space. So the way I've done that is using the theme function. Here you can add a variety of customization options. There is absolutely no expectation that you learn or memorize all of them. I think probably very few people, including the developers of ggplot2, know them by heart. But it's comforting to know that they exist. So when you want to modify the look of your plot, you can look in the help for the theme function and see what are the various things that you can do. So here we've gotten rid of the gray background and moved the legend to the bottom of our plot. And voila, this is where we finally ended up at our goal. So in this video, I tried to exemplify in the case study two things. One, we started with data that had the information we needed, but not in the shape we wanted it. And hence what we wanted to do was first to reorganize that information into a shape that then will be much easier to plot with ggplot2. And once we got that standard ggplot2 out, we then started doing some cosmetic adjustments to our visualization to make it look a little bit more visually appealing to us.